Awesome. Yeah, welcome to Microcontroller Mania. It's a bit of a very quick introduction to using microcontrollers to make tiny gadgets. It's all about electronics, bits of programming, making stuff, inventing stuff. Just like quick show of hands, who's used a microcontroller before? Who's tried it out before? A little bit. Most people beginners, right? Absolutely fine. I was a complete beginner about a year ago. My main job is software engineering and being a community manager at the Engineer Cafe. So microcontroller is something very new to me, and I found at the beginning getting started was really difficult. So I put together this event today, mainly like, how do I get started? What's the first step? What can I make? How do I start? I'm not going to run through loads of code or loads of instructions, but after the talk, I've got loads of stuff to share with everyone. And we can all try and build something, see how it goes. So I'm excited. Hope everyone's excited. So what are microcontrollers? Well, they're small and very simple computers. And this has some positive bits and some negative bits. Positive things, they're very low power. If you need something to run for 1 year on a battery, you should probably use a microcontroller. If you need something, going to be installed in a place for a long time, can't touch it, microcontrollers are great, or something as part of a larger system. They don't have much processing power, and they don't have much memory. So anyone here, I mean, you've all got laptops and phones. What kind of memory does your phone have? Any numbers? Chuck out a number.
Hard drive SSD is 256 gigs, the same as
Okay,
Pro.
256 gigs of storage, and then kind of working memory for all the calculations. RAM, about 8 gigs, 16 gigs, 4 gigs, in the gigabyte range. Looking at some of these microcontrollers, we've got memory of about 256 kilobytes, not even megabytes, or some of them around here, 8 kilobytes on the smallest one. So really, really tiny. So don't expect to be able to do any crazy calculations and things. But the plus side is you can hook it up to loads of other hardware. It's very cheap. Cool. Yeah, so some of the basics we're going to see today are inputs. We're going to have switches, buttons, sensors going into the microcontroller, and the microcontroller doing some thinking and then giving it some outputs. So LEDs, motors, servos, some networking maybe and communications. Pretty much anything electronic you own in your house will have some kind of microcontroller inside it. Your washing machine, your oven, Amazon Alexa kind of things have microcontrollers all through. So what can't you do? Well, don't expect to run it like a desktop computer. You can't do things like video and photographs, because one photograph is more than all of the memory on some of these microcontrollers. They're not really designed for interactive computing. They're clicking on things, pressing buttons, using a keyboard. That's not their sort of main focus, so probably not going to do that. And yeah, running an interactive GUI interface, screen, probably not what you're going to do. Okay. So let's just talk about a few things, just some key words before we even look at the specifics, because it gets very confusing very quickly if you don't know these. Let's switch to something real. Oops. So, just about see that. So we've got this little guy here, which is an ESP32, but there we go. So you might see this bit here. That's the brain of the whole thing. Inside that metal case is the chip. The whole metal case and the antenna is the module, see in the middle here. And then on the right, the whole thing is a development board. So that's probably what you're going to end up buying. If you just buy the chip or you just buy the module, you're going to have a tricky time programming it, a tricky time making the program. So I'll try and be careful with what I say today, but when I say microcontroller, most of the time I'm going to be talking about these development boards, the things you can buy in the shops and get going on. But inside the development board, there will be the actual chip. And if you're reading things online, or you're reading textbooks or documentation, sometimes people use both names to mean the same thing, so it can be confusing. So watch out for that, and we'll see it a bit more. OK, so here is the Raspberry Pi Pico. So it's a development board, and then right in the middle, we've got the actual chip. The bit that does all the thinking is right here. And the actual name of the chip is an RP2040. So if you're searching for documentation, you might see it written as RP2040. Well, what's good about it? We've got, we can program it with MicroPython, pretty easy programming language to use. It's actually a multi-core processor, so in terms of microcontrollers, it's pretty fast. So we can actually do quite a lot of calculation with this one. And it's pretty cheap. It's about 800 yen. You can go down to the shop and buy one now. They're everywhere. I've got loads of them today to hand out and get people to try. One I just mentioned, ESP32, similar to the Raspberry Pi Pico we just saw. Lots of pins on the edge, which is great for communicating with other devices. But the best thing, and you'll probably notice it here, is the antenna. So right on the end, there's this part here. And that's a Wi-Fi antenna. So if you really want to build a project which talks to the internet, you're going to need a microcontroller with a Wi-Fi. And so you could have this collecting temperature data, collecting, counting the number of people who walk past on the street, all that kind of stuff, and then sending it to some other service. But it's still a microcontroller. It can still run very low power, run on a battery, do all that great stuff. I'll do a little demo of that later. And yeah, go on.
Did you say it's Wi-Fi? Is it Bluetooth in there too, isn't it?
There is Bluetooth as well, Wi-Fi and Bluetooth. I was going to do a quick demo of the Wi-Fi today, but I haven't set up the Bluetooth for anything, but we can try. Yep. You can program it in MicroPython, which is a nice way to get started. Again, you can use other languages as well. M5 stack, of which we have quite a lot of them in the Engineer Cafe. These are very, very friendly, very easy to get started with. They have not just the, ooh, it's big. So it's inside this fancy plastic case with buttons on and a screen on the front is the microcontroller.
Shows the bottom again.
So the bottom is made to fit with Lego stuff.
I thought so.
Yeah, and there's a bunch of different things in this range, such as you can get this set, which is if you want to build your own smartwatch. So it's got a tiny screen here, a bunch of sensors built in, button here, so you can make your own smartwatch. Now this is all called M5 stack, and you can search for the information online, but inside this is the same as what's inside this. So when we talk about chips, they both have an ESP32 inside, but maybe this could be a lot easier to use if you're buying this development board versus this development board. So some choices there. They also make a bunch of sensors in the range where you can just plug them in and go, so no soldering, no clips, nice and easy. So M5. Yeah, going kind of the other way, these are the ATT Tiny series. So pretty small. And these are very, very small chips. They don't cost so much. If I can prop it up and you can see it. They maybe cost around 100 yen, something like that, depending on the one you buy. They have extremely small memory. They're an 8-bit chip, so you have to deal with 8-bit numbers. You can't program them in MicroPython. You have to use a language like C or assembly. Programming them requires special hardware, so it's a little bit difficult to get started. However, they're super low power, so you can write something that will run on a coin battery for a year if you want, but not very powerful. So if you need something that's just measuring a sensor, measuring a switch, turning something on and off, very, very simple. And if you read about the chip shortages that were in the news, it was these chips, basically. This type of chip that people wanted to put in cars, people wanted to put in other devices, and you couldn't buy it.
May I see it on the screen?
Ah, someone should have told me. Sorry, I can't see behind me. Anyway, sorry, yeah. So, yeah, everything I just said again, but while looking at the microchip. Cool. It is a bit hard to see, isn't it?
Yeah.
Yes. So, come have a look in person at those in a sec. What else we got? So Arduino, very popular. I'm sure people have heard about this. I've never actually used one. I don't have one. I hear they're really easy to get going and they've got good community and good tools, which is great. And if you like it, definitely use one. If you look at the chip on here, it's actually one of the same as the one we just saw, but a sort of bigger version made by the same company. So you can see how this is a development board, but it uses a chip, and you can choose to program it like this, or you can program just the chip. Both good choices. Has anyone tried Arduino before? I feel like it's quite popular. Oh, you've got one there. Oh, OK, cool. Can I borrow it?
Yeah.
Awesome. So you can see right there, this big chip is just like the chips we saw. It's actually made by the same company and kind of slightly bigger specs, but the same idea. And of course, this provides you all the USB port and easy programming stuff that you might want. Cool, thank you very much. Okay. Ah yes, the BBC microbit. This is a fun one. So if you look at the front, it doesn't look very similar to the others, right? Oops. Just yell next time I do that. So it's got a load of LEDs on the front and a couple of buttons and places to clip on crocodile clips or alligator clips and make little devices. And if you look at the back, that's where the processor is. So the actual processor is up here, and there's a Bluetooth antenna up here, and a few USB and reset buttons and things. And it has an accelerometer and a compass down there, so you can tilt it and change your LEDs and things like that. So that's quite fun. It was originally designed for children, for schools, but very easy to program with MicroPython or block languages. Again, I'll lend that out. Someone can try programming that later. OK. So if you want to choose one, if you want to get started, what should you choose? There's so many choices. Pick something that's easy to program. These guys, the tiny, tiny ones, I've wasted quite a few weekends trying to program them and setting them up and then setting them up again. And it's hard work. Pretty much every time I use a Raspberry Pi Pico, I just plug it in and program it. Way easier. So choose something easy. I recommend the Pico because you can just get one that's cheap. It's a few hundred yen, doesn't cost much. You can try it. Or if you come to the Engineer Cafe a lot, we have a lot of M5 stack that we can lend out anytime. Doesn't have to be an event. So you can try out these kind of things as well. I'll show you that in a sec. If you want to buy more or more specialized stuff, you can get stuff on Amazon. It's usually OK price. AliExpress is great. It's a Chinese website for buying stuff, but it takes a long time to get here. Sometimes you wait a month or two. And Kaho Parts, down in Imaizumi, not far from here, you can buy the ESP32, the Arduino, and the Raspberry Pi Pico there. They're really nice, really friendly. They can sell you all the components and extra things you need as well. So I recommend just going and taking a look, seeing what you can get. So Kaho Parts is a great place. Okay, let's try writing a program. Something simple. Yeah, so here is a tricky thing. Maybe you've seen some of these before. It's called a breadboard. So it's a great place to start prototyping your project. However, if you've not seen one before, it could be a bit confusing. Basically, there's a bunch of holes in the top, and the holes that run vertically like this are attached. So if I look at, say, let's go in a bit closer. If I look at, say, these holes here, just on column 1, they're all connected. So if I plug something into column 1, and then plug something else into column 1, they come out and connect up. So that's the same for all of these columns, but not across. That's handy. And then along the edge, it's the other way. So everything along this bottom red line is connected. And everything along this blue line is connected. So if you want to connect your ground and your power, that's where you do it. So that's the basics of a breadboard. If you've not seen one, it's not too complicated, but good thing to learn. The problem you get, let's take a look at a few other bits. So here's me using a breadboard, plugging stuff in. Light. It's kind of hard to see. Where can I do this? Yeah, so you can see how on the edges here, I plugged in my Raspberry Pi with some pins that go into the board, and then I plugged some other cables in next to it. And often we describe a microcontroller as breadboard friendly because if it's a good size to fit into the breadboard. However, some of them don't fit so well. So for example, this one, this ESP I showed you earlier, has the pins on, but if I put that onto here, there's no space to plug other things in. So it doesn't work as well. So you've got to think about that when you're doing it. You can do other things. You can use 2 breadboards next to each other and just have it on the side like that, or you can just plug straight into the board. But watch out for that when you're buying and making stuff. So yeah, here's some nice, easier to see pictures. Raspberry Pi, lots of space. These are ATT Tinies, plenty of space to plug stuff in. ESP32 development board, kind of hard. Cool. Many, many different ways to program these microcontrollers. Arduino IDE is very popular, not just for Arduino, but for other things. But today we're going to mainly use Thonny, which is a MicroPython and Python IDE, and M5 Flow, which is one for these ones with the screens. And there's also a bunch of other command line tools, extra tools, all sorts of stuff. You can take it really far. So if you've got a computer and you're going to use it later, you'll probably want to install Thonny today. The setup is super simple. You basically just install Thonny and then plug in your device. I've got a cable here. So if I've got, say, let's do one of these ones with nothing to attach. I want to go to Thonny. So ignore that for now.
You want to make sure you've got a good cable, a data cable. I went through quite a few cables before I found out that wasn't working.
Oh, so what was wrong with your...
Because they're just cheap power cables, they weren't data ones.
Ah, yeah, that's a really good point, actually. So some of these cables don't have any connection for data. Most of them are using USB micro. Some of them are just power for like charging phones. If you're ever not sure, we do have a cable tester at the Engineer Cafe, so you can bring your cable, plug it in, it'll tell you if it's power, if it's data, if it's USB-C, it will tell you there's lots of levels to USB-C.
I was plugging Android devices into my
And didn't work? Ah, that's a good way to test. Yeah. USB-C is a bit more complicated because the cables, there's a few different types. Okay. So you plug it in like something like that. Get it to stay on camera. And here we go. So you've got your Thonny down at the bottom. There's a little bar which will let you go here and so choosing the device. So here we're going to choose the Raspberry Pi Pico. We're going to find out where it's plugged in. Oh, I hope this cable's good enough. Anyway, give it another try. Let me try restarting Thonny. So Thonny is generally quite good, but occasionally it's a little bit buggy. And of course, I tried everything out before this. That's not a good sign. Try a different cable. I think it might be the adapter, to be honest. Thank you. Yeah, so like I said before, once you get your programs running, you tend to get through everything quite quickly, but actually getting the program running can be a different story. Okay, Raspberry Pi Pico. Just see if it'll do it. Okay. Oh, it's going. Okay, so fiddle around with these settings here. You won't actually see anything happen on your device, but this is, you only have to do this the first time. This is just loading up the MicroPython firmware.
There's something you had to hold that debug button down as you stuck the USB in for the first time, I recall.
Might depend on your dev board as well, and what you're using to program it.
Those are the instructions I was following, isn't it?
Yeah, so again, there are many different ways to program them, and even some of the boards that look very similar can have different setups. So that might have been correct for your board. So hopefully now we can actually use it. So I've got some very simple code here. All it does is get some libraries, set up one of the pins, and the Raspberry Pi Pico has an LED built in. So hopefully we're going to go around this loop and turn the LED on and off. That's all it does. So toggle turns it on and off. Sleep waits for 1,000 milliseconds, and then we repeat. Do that 100 times. So hopefully it works. Whee! So you can see that little green LED is blinking away. And I think if everyone manages to get to this today and then they can start playing around, I'm happy. The other thing you can do is you can actually write Python commands down here if you want to. So you can try, let me copy some of these lines. Oops, sorry, I have to import first. Hang on, can I do picture in picture? Oh, not there though. Not there. Right, there we go. So hopefully you can see that. So now I'm going to set up the pin 25, which is the pin of the LED. And then I'm going to turn it on with the toggle function. Go on. Might have crashed. So that's unfortunate. Come back to that. So that's the basic process of programming it with Thonny. So has anyone here written Python before? Tried a little bit of Python, even just a code or a script? I think So this will look really familiar, right? But it's not Python. It's MicroPython. So you've got to watch out. So you can't necessarily do everything that you might expect to do here. The basics are pretty much the same if you want to do loops and functions and if statements and stuff like that. But when you start getting into things like big calculations and big amounts of data, well, you can't do it because the microcontroller can't do it. So if you're already kind of pretty familiar with programming, check out the MicroPython documentation, and you can see some of the differences. OK. I might skip this part for now, because it gets a bit detailed. This is how you program the M5 stack. A little bit different. So let's do it from scratch. So the first thing you're going to need is to plug in your M5. They do have a battery inside, but it doesn't last very long. And the first thing it does is searches for a Wi-Fi network that you need to set up, and then it gives you a key. And what you can do, it's a little bit magic and a little bit fancy, but if you go to flow.m5stack.com, it'll load up this. You go down to the bottom left, type in the code, 26ED, so I already had it typed in here. Cool. And choose your device. So there's my device. If you watch that bottom left corner, should switch over to connected in a moment. Not if everyone's watching, though. I wonder why. Ran through the whole demo like. Oh, always the way. That's on the Wi-Fi. This is on the Wi-Fi. That is a shame. Anyway, when it connects for you, which I'm sure it will first time, you can put in some code like this and get it to run. Oh, that's why. Because it's connected on here, I think. Brilliant. Yeah, so you can set up some code. And this is the Blockly language, which is nice drag and drop block programming if you want to try that. So you can just put commands if you've tried Scratch or similar. The nice thing is you can click here and get the Python for the same code. So you can make your program and then take a look at what the Python is. And so this is using a thing called NeoPixels, which is these kind of multicolored red, green, and blue pixels. So if I plug it in, ooh, I can't remember which pin I used. 21. Okay. Awesome. It's a little bit hard to see. Maybe if I turn off the light, if I can reach. Ooh, spooky. But basically, I've got this ring of LEDs, and it's turning them on and off and on and off very quickly using the code that we saw in the editor. Not very easy to see like that, though. You can just about see. Yeah, so again, these red, green, blue pixels you can use with all of the microcontrollers in various different ways. It's just nice and easy to get set up on here. Cool. OK. One thing that's really, really convenient when you're working with these microcontrollers is finding a pinout. So this basically will tell you what all of the different pins can do, the different things. So some of them are power, those red ones in the top right. Some of them are ground, for connecting up a circuit. Some of them are different types of connections and communications protocols. And different things need to be connected to different places. So I find if you're working with this, print out one of these. Put it on your desk so you can keep looking at it while you do stuff. And one last thing is if you don't have a Raspberry Pi Pico, or you can't get one, or can't get it working for now, there is a simulator online which will let you write MicroPython here and build your circuit on the left, so you can put in like an LED and connect it up to the different places. So this is a fun way to practice and make prototypes. And then I think I should be able to just copy and paste my code. Oh, Thonny's crashed, hasn't it? Anyway, force quit. It's the first time I've ever had it crash like that. Okay. And you can do things like test your code, and then put it up there. So my suggestion was, if you wanted a challenge, you're feeling pretty confident, is try and make a countdown timer with like a button to add minutes, a button to add seconds, a start button, LEDs to show when it's up. And here's some other ideas of things you might make in the future. All these slides are on the event page as well. You could try building something, LEDs and buttons, try using Wi-Fi, making a little battery-powered device, making an analog sensor, wireless remote control, all these different things you could make. There's some useful links. The simulator I just showed, Thonny, the MicroPython documentation, and a few other links I think are pretty good. There's that blog at the top is really, really detailed if you want to get into these tiny, tiny microcontrollers. This Life with David is a video series which is very detailed on the special features of the Raspberry Pi, the programmable I/O. All About Circuits is a really, really detailed free textbook if you want to learn more about electronics and you feel like you don't know. Hackaday is just a fun blog if you want to try getting some inspiration and look at other projects people have done. So that is basically my talk. I've just run through it as quick as possible. I can do a few more quick code examples if I can get Thonny to work. I'll take a few quick questions, I guess, if anyone wants to ask. Or if people just want to start and try and make stuff, I can hand out all the devices and we can go. So any questions, anything you want to check?
What's the simulation? Can you give us the
Yeah.
simulation?
So if you go to the event page on Compass, there is the links to the slides as well. So all the links there you can click through, or you can type in the address. So that's a good way to get started if you're waiting. Everyone just wants to get going, don't they? Okay, let's start. So what I'm going to do is, let's hand out some M5s first, because we've got loads of these. Wait. So we've got these tables at the back as well, and maybe around the edge. I think we've cleared everyone else out. So if you want to try an M5 stack device, come grab one of these, try it out. That's a kind of watch, smartwatch thing. If you want to try Pico, I've got a few Raspberry Pi Picos I can lend out to people. Also, if anyone wants to try soldering the pins on, there's a soldering iron over there, and I can set up that.
Just in case.
Yeah? But yeah, so whoever wants to try one of these, come grab one. But basically, that's all the talking done. Let's make some stuff. Cool. Yeah. So I'll just float around for the rest of the evening getting people going. So Probably best to spread out so we have enough space, but come grab a device, grab one of these, grab one of these, grab a Pi Pico, anything you like.
It's just like Lego.
Yeah, it's like electronics eat Lego.